This video covers the second part of the Unit 8 exam. This part deals with titrations of acids and bases. The first thing you need to be aware of when starting a titration calculation is that titrations are going to incorporate a lot of our prior knowledge. We have to be able to write and balance a formula equation. We have to be able to calculate moles using molarity of solutions. And then we have to do some stoichiometry with the acid and base. So let's go ahead and get started. Alright, so I notice I have sodium hydroxide, that's my base, so NaOH. Sodium is 1 plus, hydroxide is 1 minus, so NaOH. And then hydrochloric acid, we haven't done any real nomenclature of acids, so HCl is what hydrochloric acid is. So as the first thing you have to kind of recall is that when you have a neutralization, the first thing that always forms is going to be water. When you have the cation from the acid, the hydrogen, and the anion, the hydroxide from the base, H and OH, that makes H2O. So that's your water. And then what's left over? Well, I've got sodium from the sodium hydroxide and chloride from hydrochloric acid. That's going to make just regular old table salt, sodium chloride. This reaction happens to already be balanced. Alright, so now what I need to do is I need to calculate the number of moles of hydrochloric acid that I have, because you notice I have both the molarity and the volume, and so I'm going to use the formula molarity is moles of solute per liter of solution. So in looking at this, let's see, I'm going to substitute in my values, so 0.75 molar. And then I do not know the number of moles. I'm going to call that X. And now notice the volume is in milliliters, but for molarity it must be in liters. So therefore I'm going to have to convert 14 milliliters. Essentially in 1 liter there are 1,000 mils. So you can divide, which you're essentially going to be moving the decimal point 3 places to the left. So this becomes 0.014 liters. All right, and now in order to solve this for x, we've got to use our Algebra 1 skills. I need to get x by itself, so I'm going to cross-multiply, essentially multiply both sides by 0.014. So if I multiply 0.75 times 0.014, my calculator spits out 0.01, and then if I round it to sig figs, 1 moles of hydrochloric acid. So now I know the moles of hydrochloric acid. Well, I can now use stoichiometry to convert from moles of hydrochloric acid to moles of sodium hydroxide. And then once I know the moles of sodium hydroxide, I know the volume. I can use the molarity formula to calculate the molarity of the unknown base. So, in looking at this, 0.011 moles of HCl, my hydrochloric acid. While I look at the balanced formula, everything is in a 1-to-1 ratio. So for every 1 mole of HCl, there is 1 mole of sodium hydroxide. The hydrochloric acid cancels. Multiply and divide by 1 you don't have to do, so 0.011 moles of sodium hydroxide. Now that I know the moles of sodium hydroxide, I can substitute these back into the molarity problem, or the formula. So here are my moles, and then I look at the volume. It says 38 mils, so once again I must convert to liters. So I move the decimal place 3 places to the left, 0.038 liters. And if I divide this, you end up with 0.29 molar NaOH. Okay, we'll do the same basic premise with this problem. I have to start out with a balanced formula equation. Once again, I have sodium hydroxide as my base. This time I have acetic acid, so HC2H3O2, that's acetic acid. Okay, and let's see what they're going to form. So once again, for all neutralizations, first thing we got is water. Then we have to look at what salt is left over. It's going to be sodium acetate. Sodium is 1 plus, Acetate is 1 minus, so it's NaC2H3O2. Nacho. That's sodium acetate. Okay, so anyhow, same thing. We're going to calculate the moles of, it looks like we're going to have to do the acetic acid first because we have the volume and the molarity of that. So I'm going to substitute in what I know. So for the molarity, I have 0.0140 molar acetic acid. I do not know the number of moles, but I do know the volume. So once again, converting this to liters, 0.0142 liters. So if I cross multiply, so 0.0140 times 0.0142, I end up with a molarity with sig figs of being 0.000199 moles of acetic acid. Now that I know the number of moles of acetic acid, I can use stoichiometry to convert to moles of sodium hydroxide. Once again, this is a 1-to-1, so it'll be very simple. It'll take more time to write out the equation than it will to actually solve it, because I hope you realize we're going to be multiplying and dividing by 1. But once again, you need to show your work. So for every 1 mole of acetic acid, there is 1 mole of sodium hydroxide. Acetic acid goes away. Surprise, surprise, you still get the 0.000199 moles, and now this is of sodium hydroxide. So we have converted from one substance to the other. Now we have to solve for the molarity, once again, of the sodium hydroxide. Molarity is simply moles divided by liters. So there's 24.6 liters, or excuse me, milliliters, so I have to move the decimal 3 places to the left. 0.0246 liters. If I go ahead and divide this, my answer should have 3 sig figs, so it should be 0.00809 molar sodium hydroxide. All right, another titration problem. This time we have sulfuric acid, so H2SO4, and to this we're combining calcium hydroxide. Okay, so once again, we've got to balance this formula. We're going to form some water, and then what's left over? Calcium and sulfate, because calcium and sulfate are both 2 charged. Calcium's 2 plus and sulfate is 2 minus. Equal and opposite cancel. The formula for calcium sulfate, CaSO4. Now to balance this formula, you'll notice that the hydrogens and oxygens are not balanced, but that's easily remedied. All you have to do is put a 2 in front of the water. All right. So once again, let's start just as we had with the other problems. We need to find the moles of the calcium hydroxide because we know the molarity and the volume. So I'm going to say, well, we have 0.010 molar calcium hydroxide. We do not know the moles, but I know the volume is 19.8 mils, so if I move the decimal 3 places to the left, you get 0.0198 liters. Okay, to solve for x, cross multiply, so 0.01 times 0.0198, and you end up with 0.00020 moles of calcium hydroxide. That's with sig figs, rounding to 2. Okay, so now that I know the moles of calcium hydroxide, once again, we've got to convert to moles of the sulfuric acid. 0.00020 moles of calcium hydroxide. Well, once again, you'll notice the acid and base are in a 1-to-1 mole ratio from the balanced formula, so it's going to end up being the same again, but you got to show it. So 1 mole of calcium hydroxide is 1 mole of sulfuric acid. Calcium hydroxide cancels, so I end up with the exact same number, the 0.00020 moles, but now it is sulfuric acid. All right, so I know the number of moles, I know the volume of sulfuric acid, so I can determine the molarity. 12.4 milliliters listed as liters is going to be 0.0124 liters. If I divide, you should get 0.0161 molar sulfuric acid. All right, down the home stretch, last one. Same thing, another neutralization, so we need a balanced formula equation. Here is the base. We have barium hydroxide, and to this we're going to combine it with hydrochloric acid, and so it's going to make, once again, water, and then let's see what's left over. We have barium and chloride left, and because barium is 2+ and chloride is 1-, the formula is BaCl2. When I go to balance this, okay, you're going to notice that I need 2 chlorines on the reactant side, so if I put a 2 here, that fixes the chlorines. Now the hydrogen and oxygen are messed up, but if I put a 2 in front of the water, that should fix it. So now I have 4 hydrogens on both sides and 2 oxygens. So there's our balanced formula equation. Just as before, I know more about the hydrochloric acid, so because I know the concentration and the volume, I can solve for the number of moles. So 0.25 molar HCl. Well, I know that there are, let's see, the volume is going to be 0.0122 liters. And when I rearrange or solve for the number of moles, I'm going to multiply both sides by 0.0122. And in doing so, let's see, I get, let's see, 0.0031 with sig figs moles of hydrochloric acid. All right. Well, now I have to convert those moles of hydrochloric acid to moles of barium hydroxide. Hey, we've got one that's not a 1-to-1 ratio. Awesome. So looking at the balanced formula, according to that, for every 2 moles of hydrochloric acid, we want to put that on the bottom so it cancels, there is 1 mole of barium hydroxide. Moles of hydrochloric acid cancel. If I divide, I get 0.0016 moles of barium hydroxide. Now I'm going to substitute this into the formula. This time it's asking for the volume, so this one's a little different. I was given the molarity, so 0.12 molar barium hydroxide. Now I know the moles is 0.0016 moles, and now I'm solving for the volume. That's going to be the denominator. Essentially, you got to get x by itself, so you're going to cross multiply. So essentially what's going to happen is that these two things are going to switch places. You're going to multiply both sides by x, which is going to put x up here. Then you're going to divide both sides by 0.12 molar, which will cancel on this side, and it'll bring the 0.12 molar down here. And so when you solve it, it's going to look like this. You're going to have the 0.0016 moles divided by 0.12 molar. That's going to equal our volume. And when you do that, you end up getting 0.013. The unit is liters. Or if you wanted to put it in milliliters, you could move the decimal 3 places back to the right to make it 13 milliliters. Either answer would be acceptable.